So, ladies and gentlemen, those were our startups from the hardware field. Again, please, a big round of applause, because I think I did a really good job at their presentations. And let's now move over to the topic of materials and applications. And we will start with another winner of the Startup Challenge in the first place. And secondly, not only that, they also won the AM Ventures Impact Award. And for me, it's absolutely clear why they did this. We are talking about LATTICE Medical, who are dedicated to a very important topic of our time, and are making a real contribution, in my opinion, to improving the situation of many women in the world. Julien Payen, I hope I put it correctly, CEO of LATTICE Medical, explains how they achieve this and what is so important about it. Julien, pleasure to have you here.
Thanks. Hi everyone. It's a real pleasure to be here today to present LATTICE Medical. So LATTICE, we have developed a patented and unique technology to regenerate human soft tissue by combining biomaterials and 3D printing. The first application of the product concerned the breast cancer and mainly the breast reconstruction. Do you know that 1 woman on 8 will suffer from breast cancer in the world? And today the main treatment is still the surgery. We remove the breast tissue. It's called a mastectomy. And we have only 1 woman on 5 having a reconstruction. Because in one hand, we have the silicone implant bearing long-term problems and autologous surgeries, really long, 10 to 12 hours or iterative. Our vision is to replace the silicone implant from the breast surgeries. How we do that? We introduce LATTICE. LATTICE is a tissue-engineered implant with 3 features. The first one, LATTICE, this is the product, enables the regeneration of adipose tissue, the fat tissue of the breast. The product is fully degradable over 18 months. It disappears, like a Suturian. And the surgery takes only 1 hour. I have a short video to introduce the concept. In that case, we have a woman. She had a mastectomy on the left breast. We use the same entryway. We don't add new scars. The surgeon will harvest in situ a tissue, what we call the flap, in the intercostal area. And this flap will be inserted into LATTICE. LATTICE is in 2 parts. The bottom part is called the scaffold to fix the tissue. And then we close with the chamber, can have different shapes and different size thanks to 3D printing. And once implanted, the tissue regenerates inside, and slowly the implant disappears, degrades into the body. After all, the patient gets back a new breast with its own tissue naturally. The company was created 5 years ago. We have raised already 10 million euros to achieve very big milestones. The first one was to prove the efficiency into in vivo animal studies. Here, in this example, you have the LATTICE implanted black dots, and we follow the regeneration with MRI. And you see in this example, only 90 days to regenerate the tissue inside. And we run a very long-term study during 2 years. And the full size is reached between 3 to 6 months. We pass with our process the whole biocompatibility to prove that the process, the material, the product is safe. And we have created a printing farm to produce, so we produce from the biomaterials to the end-use sterilized product. With this factory, we use very common printers, Ultimaker systems, but we have run all qualification and validation process following the ISO guidelines. And we produce the filament and the product. And finally, everything leads to the possibility to start the first in human. We have implanted the first patient this year. She's really well. She's happy about her reconstruction, and we are really happy about her. And just to finish, wow, it's not the colors. We raised a Series A recently to cover the clinical trials in 8 centers in Europe involving 50 patients. We are assessing the FDA to do the same in US. And we have a plan to mount an industry, so to scale up into an industrial scale. start the clinical trials in US and commercialize in Europe in 2026 after the clinical trials. Thank you very much. We have a booth in the B81 Hall 12. Thank you.
Very impressive, Julien. Thank you so much. Really a pleasure. Are there any questions from the audience before I ask my question? There's one, please.
No, it depends on the size.
Can you repeat the question for the...
how long it takes to build the product? Depending on the size, it goes from 15 hours to 30 hours. And the idea for the production system is to have 200 printers like this.
My question would be, Julien, how difficult was it to overcome the medical regulation? Because this is normally something that is really a big hurdle if you want to come up with such a product.
You have to apply the rules. The rules in Europe are moving, and it's really hard. And a lot of companies in medical area are going into US. So we have to follow the rules, but find the right place. In the development, you need to be innovative, but not too much. If it's too much innovative, it's too long and too difficult, too expensive. And you have to not forget that it's for surgeon, it's for patient. It needs to be surgically affordable and also in terms of price.
Awesome. That was, by the way, a good tip for other startups in this sector. Thank you very much, Julien. Great applause for you.
Thank you.
Winner of the Startup Challenge and the AM Ventures Impact Award. We will see you later at the award ceremony. Thank you so much. Great. So some of you already know them from the AMTC 2022 in Munich, where they won participation in the Pitchnext event with a very good pitch, in my opinion. Faster, higher, stronger. Join me in welcoming Fortius Metals and their CEO, Jeff Lints. Jeff, good to have you back.
Fortius, the name comes from Sidious Altius Fortius, the old Olympic motto for faster, higher, and stronger. Hello, I'm Jeff Lints, CEO and founder. Fortius Metal is based in Boulder, Colorado. We sell wire and we sell parts. So we have our own wire factory, and we also have 2 robotic cells capable of manufacturing large parts, one in arc welding and one in laser welding. So we think that large format metal 3D printing is the next big wave. You can see on the right there this video from a company called Relativity Space, which has fantastic marketing showing what our industry can do. That's about a 3-meter diameter tank being printed. In addition to the traditional benefits of 3D printing, like more complex shapes, reduced part count, we think big parts are a big deal because of radically reduced lead times. So if you're making a big part using traditional fabrication techniques, you're looking at 18 to 24 months lead time with custom suppliers and very expensive tooling. We can do this in just a few weeks with 3D printing. What makes Fortius Metals different is our metallurgy. We weld the unweldable. In the top, you see an image of an aluminum weld. This is 6061, which traditionally cracks and is unweldable. We solve that problem, and in addition, our welds, our materials, are often stronger, sometimes twice as strong as the wrought equivalent. So this is an example. We control that through metallurgy. On the left, you see what's typical, the long, skinny grains that are, have a tendency to crack. We solve that by adding grain inoculants or refiners, which we'll call pixie dust for today's conversation. That creates massive grain nucleation, creating fine, equiax grains which add strength. And any leftover pixie dust precipitates out, further inhibiting cracks. Fortius Metals, we believe we have to solve the whole customer problem. That means in addition to our advanced alloys in nickels, titaniums, aluminums, we're also process experts, both in arc and laser, and we support electron beam as well. We also help our customers design for additive, and we help solve for distortion control. So our company, our technology has already been commercialized in the market. Fortius Metal spun out of another successful company called Elementum 3D, who's been selling these alloys in powder form for powder bed fusion. Elementum focuses on powder, Fortius focuses on wire. It's a great collaboration. We already have a range of great customers because of that heritage. And then in addition to 3D printing, our welding wire can drop into any factory with traditional welding. That's a big deal because we think we can help things like electric vehicles. Stronger welds means lighter frames and lighter chassis, which means extended range for EVs. So thank you. I look forward to your questions.
Awesome, Jeff. I know I can rely on you what the timing concerns. Awesome presentation. Any questions from the audience? There's one. Can we repeat the question?
Yeah, the question is, how much funding are we looking for? So we're just about to close our seed round, and I'm probably looking at a Series A in 2024. And hopefully that gives us enough time to get traction to have a very large round.
Very good. Any more questions here from the audience or from you at home? If not, let me ask one quick question. I mean, we are talking about the automotive industry, especially EV. How far is that away? Because I'm from automotive industry, I'm interested, when can we use your wires in automotive production?
So materials businesses are fantastic and a little bit challenging because things take time. So we have a very, I think, sober view that we need to start today to get these into our automobiles in 5 and 10 years. The first adopters are often commercial space. They're going to market now. And to get human transport and all the testing and all the qualification, we're starting now to make those vehicles safe for the next platforms.
Very good. So there's one question from the online audience. What is in the dust?
So that's our proprietary technology, essentially a ceramic grain inoculants that have an in-situ reaction. And I would love to talk further about that offline because we don't have enough time here. Upstairs in booth D54, we're hanging out the Elementum 3D booth today.
Visit Jeff there. Jeff, thank you so much.
Thank you.
Great having you. So one of my favorite topics, to be honest, is circularity. And it's undeniably one of the most exciting topics of today. Rudolf, Jonas, and Jörn think so too. They are tackling the issue with a recycling Fabrik, and Rudolf tells us how. Rudolf, please, stage is yours.
3D printing and plastic waste. Together with Jörn and Jonas, I found the Recycling Fabrik to create circular economy in 3D printing processes. Because plastic waste is one of the largest problems in our world, even in 3D printing. We identified the problem that even in 3D printing, old prototypes, misprints, and so on are mixed up with most common waste and is getting burned anywhere. We developed a solution, a circular economy, to collect this 3D printing waste directly from customers and 3D printing users. We have a regranulation and post-processing that guarantees high-quality granulate that you can use in our extrusion again to get high-quality filament that is ready for new 3D printing. For companies, we developed special services. When you have larger amounts of waste, it is possible to get back your own material as recycled filament or granulate for your own 3D printing. Also, when you are in prototyping like medical development, we can guarantee data protection compliant recycling. So there's a priority in process. And all this without any waste disposal costs. We pay and organize the shipping. So it's free waste management. And for all this, we need you to get 3D printing more sustainable, to get corporations. So stay connected and find us in Hall 12-1, booth 101E. Thank you very much.
Awesome, Rudolf. Applause. I have one too, to be honest. How is that financed?
It's quite good.
Now, where do you make your money with? That would be my question.
We make our money with the whole process. So we do everything by our own. We have the machines for grinding, for granulating, for extruding. So nothing is outsourced. So we have our hands on the quality and the control of the material.
So finally, you get the waste. Let's say I have a company, I give you my plastic waste from my prototyping. You reuse it, by the way, and then you sell it back or you sell it to another customer with your new filament, right?
Yes, and even when you are sending us waste, you will get a reward from us. When it's sorted by material type, you will get some points that you can use in our online shop as a discount. So you can save up to 25%.
Bringing us to the next question, sorry, I don't forget the question of you. There's one online question which I really like. How do you deal with a change in polymer properties after each melting and cooling process? And can you ensure that the material is good enough to be used again?
That's quite a good question. So we have quite large material batches, like 300 to 400 kilograms. And we say to our customer they have to sort by material type. Due to the high waste stream that is growing every month and every time, we never it's not that common that we get back the same material and recycling the same material. And we have some kind of homogenization. And due to this, it's quite common that we get the same properties of the material every time. And we can test this with some material tests.
Very good. Then we take your question. So just to repeat the question for the audience.
Yes.
So is it more expensive to recycle? Yeah.
When I just want to make money, I will produce new filament. But that was not the goal. The goal was to create a sustainable alternative to new material. And due to this, even the material is not that high price, because we said it should be a product that everyone has a real alternative to buy new or recycled material.
Awesome. Thank you so much, Rudolf. It was a pleasure to have you here. They can visit you at your booth and go into circularity. I really appreciate that. Thank you so much. So they had been winner of last year's Startup Challenge, and that makes it even more interesting as we can see their progress. Please welcome Azul 3D, represented by David Woodlock, Head of Growth. David, what have you brought us with you? I see. Oops.
Hi, everyone. I did not present last year, so it doesn't count as a second try. My name is David Woodlock. I've been in the industry since about 2016, the first 6 of those years at HP, bringing production applications to market. I moved over to Azul 3D because I saw an opportunity here to move printing into new levels of throughput from a first principles level that are tied to physics. So about 6 or 7 years ago, there was this huge step change in the industry. And that was kind of a move from point-based processes to area-based processes. You saw that on the thermoset side with resins, and you saw that on the thermoplastic side. This was SLA getting really disrupted in a lot of industries by DLP, DLS, carbon, et cetera. And SLS really getting challenged by HP, multi-jet fusion, and some of these new high-speed sintering processes. And the reason to go point-based to area-based, higher throughput, but also consistency of mechanical properties throughout a layer as you get better fusing, entanglement within that single layer. But you start to run into physics. You're printing so fast, you're just dumping energy into the system continuously. And that starts to become the limiter of your throughput. It's like running injection molding without cooling lines. You're slowing down because you have to wait for heat to naturally dissipate out of the system. So it doesn't matter how fast you can print because you're putting too much energy in without taking any energy out. And there's a few rules of physics in there. What we're doing is we think we're targeting a brand new space in the whole 3D printing ecosystem by being able to actively remove heat from the system. So while DLP can go really fast, it's fundamentally limited in scale. And while laser systems can go really large, they're fundamentally limited in speed by being a point-based system. We're trying to go after this fourth box where we can take the best advantages of both of those into a new architecture. And this is the fundamental invention that drove the formation of the company. And what you're seeing here is a layer of oil that sits above the projector membrane that continuously flows across that membrane. And it does a few things, but the one I'm going to highlight here is it continuously pulls heat out of the system. So we're no longer fundamentally limited by the amount of energy that we're putting into the system. That means we can now print at speeds not limited by keeping a stable thermal experience of the plastic. So projectors, membrane, layer of oil, resin sits on top of it, we're able to pull parts without influencing that oil. So as you can see here, what we're doing is we hit a stable bed temperature at much higher speeds for much taller builds without increasing the heat. So at the top, you can see a printer with no oil. You can see a printer with moving oil. And then you can see moving oil with cooling to that oil. We're refrigerating it on the outside of the printer. And this is what's going to allow us to do high throughput, really fast, really tall builds with the consistency of mechanical properties and other surface finish, dimensional accuracy, things that are going to be required into production applications that would take advantage of the speed. The other thing that we're doing is we've developed a material strategy to take advantage of this architecture. And so we specialize in low viscosity resins. When you take that liquid-liquid interface and you add on low viscosity resins, we can actually refill material under the part fast enough that we pull continuously. We do not turn off the servos. We do not turn off the projectors. This is great for speed, but it's great for better mechanical properties because there's no longer any layers. Truly no longer any layers. You get full entanglement layer to layer across all of the parts because of that continuous pull. We do custom materials, again, targeting production applications, knowing people have different requirements. We formulate materials specifically for your need to be able to take advantage of our system. First public customer, Wilson, taking over the pickleball world, which is the fastest growing sport of all time in the United States. Thank you.
Thank you so much. Great presentation. Questions from the audience? There's one. Can we repeat the question quickly? Sorry.
Yeah, what's the business model, and do we sell printers or do we contract manufacture? We lease printers and we sell material. We will do some part production as needed to get the business off the ground and get parts in people's hands, but it's not the end business model.
Thank you so much. Any more questions? Then thank you so much for being here. Applause, please.